let's look at how to determine the difference quotient for a couple of different functions. First, let's look at a quadratic function. So given the function f of x equals negative 3x squared, let's determine the difference quotient. So let's look at this in a couple of steps. The first thing that we're going to work on finding is f of x plus h. So this is going to be one of the pieces that we need to plug into our difference quotient formula. So when we're finding f of x plus h, we're evaluating our function at x plus h. So we want to replace the x with x plus h. So we'd have negative 3 times x plus h squared. So this would be the expression before we did any simplifying. Now let's work on the simplifying. So this is the same as negative 3 times x plus h times x plus h. So just as a reminder, anytime you see a binomial squared like that, so say you had something like x minus 3 squared, be sure that you're always squaring the entire binomial. So think of this as x minus 3 times x minus 3, and then we would FOIL from there. So x times x would be x squared. We'd have minus 3x, and a plus 9, which gives us x squared minus 6x plus 9. So notice that's not the same as just squaring the x and squaring the 3. We need to actually square the entire binomial. So in our expression, we're squaring the binomial x plus h squared. So I'm going to start with FOILing my x plus h times x plus h. So negative 3 times, we'll have x squared plus xh plus xh plus h squared. Or we could combine that to be x squared plus 2xh plus h squared. And then last we'll distribute the negative 3. So notice that the multiplication comes after the exponent in our order of operations. So we have negative 3x squared minus 6h minus 3h squared. So the first expression that we wrote down would be what we have before simplifying, and this is now what we have after simplifying. So now let's think about the actual difference quotient that we want to find. So our formula for the difference quotient is f of x plus h minus f of x all over h. So this is really just an average rate of change problem when we're doing a difference quotient. So the first expression, so kind of thinking through this in an unsimplified form and then a simplified form. So f of x plus h, we saw we started with negative 3 times x plus h squared. So that's our f of x plus h minus f of x, that's our original function, negative 3x squared all over h. So when a problem asks for it to be unsimplified or before simplifying, this is where we're starting with our difference quotient. But we just did the work to find that when we simplify our f of x plus h expression, we have negative 3x squared minus 6xh minus 3h squared minus our negative 3x squared all over h. So we have some like terms in the numerator. The negative 3x squared minus a negative 3x squared cancels. So we're left with negative 6xh minus 3h squared all over h. So each of those terms in the numerator is being divided by that h in the denominator. So it's going to cancel an h out of each of those terms. So this leaves us with a negative 6h minus 3h. So from the h squared, one of the h's is canceled. So our difference quotient for the function f of x equals negative 3x squared will be negative 6x minus 3h. So this was for a quadratic function. Now let's look at if we have a rational function. So same question, determine the difference quotient, but this time our function f of x is 6 over x. So when we go to think about f of x plus h, there's not really any simplifying we can do this time. It's just going to be 6 over x plus h. So let's go ahead and go right to our difference quotient formula this time. So f of x plus h minus f of x all over h. So f of x plus h, plugging in x plus h as our input, is going to give us 6 over x plus h minus f of x, our original function, is 6 over x all over h. So we have what is called a complex fraction, meaning that we have fractions inside of a fraction. So we would like to simplify this so that it's still going to be a fraction, but we won't have the fractions inside of the fraction anymore. The way that we can do this is to look at kind of the mini fractions, those small fractions showing up in our numerator, find the LCD or the common denominator for those denominators, and then multiply our entire fraction by that LCD. So since the two types of denominators we have are x and x plus h, what I'm going to do is I'm going to multiply this big fraction times x and x plus h on top, and then also times x and x plus h on the bottom. So you can see I started with one fraction, one complex fraction. I'm multiplying this times a fraction that has a value of 1 because it has the same expression in the numerator and the denominator. So now in the numerator up here I'm going to need to multiply each one of these terms times x and x plus h, and then in the denominator I'll multiply as well. So this is going to give us our 6 over x plus h needs to get multiplied times x and x plus h, minus our 6 over x also needs to get multiplied times x and x plus h. And then in the denominator we have the h that we started with times the LCD, the x and x plus h. Now some things will cancel here for us. So looking first here in the numerator, the x plus h cancels with the x plus h, and the x cancels with the x. So in the numerator we're left with 6x minus 6 times x plus h. In the denominator we have the h, the x, and the x plus h. So we still have a fraction, but it's no longer a complex fraction, meaning there's no fractions inside of the fraction. We can simplify a little bit further if we go ahead and distribute here. In the numerator we have 6x minus 6x minus 6h all over hx times x plus h. So the 6x minus 6x cancels, and we have negative 6h all over hx x plus h. And then we can even cancel this factor of h with this factor of h to give us our final answer of negative 6 over x times x plus h. So this is our difference quotient for the rational function f of x equals 6 over